Welcome to Chapter 5, The Dynamics of Uniform Circular Motion. So we're going to start this chapter with a question. How can an object be moving with a constant speed and be accelerating at the same time? We talked about this a little bit in class today. I'll give you a hint. That's right, objects spinning around in a circle. Uniform circular motion is the motion of an object traveling at a constant speed on a circular path. So the speed stays the same, only the direction changes. Here's an example of a toy plane tied to the end of a string. When you spin the plane around in a circle, the speed of the plane, which is the magnitude of the velocity, stays constant, but the vector is constantly pointed in a different direction. So let's handle the speed first for something moving in circular motion. How do we calculate speed? What two things do we need to know? Well, what are the units for velocity? That's right. We need distance and we need time. But you knew that. So let's start with the time. The time it takes for an object to travel once all the way around in a circle is called a period. And that is with a capital T. So instead of a lowercase t for time, the capital T is a special kind of time, and that's the time it takes for an object to go all the way around in a circle one time. Now for the distance, we just use our equation for the circumference of a circle, which is the circumference equals 2 times pi times the radius of our circle. So now when we put these two things together, we get the magnitude of the velocity, otherwise known as the speed, is equal to 2 pi r divided by the period. Make sure you write this down. Let's take a look at an example. In this example, the wheel of a car has a radius of 0.29 meters, and it's being rotated at 240 revolutions per minute. It means it's going around 240 times every single minute while driving down the street. Determine the speed in meters per second at which the outer edge of the wheel is moving. So the first thing we need to do is we need to take a closer look at our equation for the period. The period is the time in seconds over one revolution. The time it takes for one revolution. So now we just need to plug everything in and convert. If we have 240 revolutions per minute, otherwise known as RPMs, we can also write that as 1 minute for every 240 revolutions. And then to get rid of minutes and put it in seconds, we have 60 seconds over 1 minute. Gives us 0.25 seconds for every revolution. So our period is 0.25 seconds. So now to find the speed, we just do the circumference, 2 times pi times the radius, divided by the period, 0.25 seconds. So the speed is equal to 7.28 meters per second. So now that we can calculate the speed of an object in circular motion, we need to think about what Newton taught us about an object in motion. What was Newton's first law again? That's right. An object in motion tends to stay in motion along a straight line. So what do we need for circular motion? Well, if the velocity is going to change direction, then our object must be accelerating. Now remember, uniform circular motion is a special condition where the speed of our object as it moves in a circle remains constant. So if the speed remains constant, the only thing that's changing is the direction of our velocity. In order to accomplish this, we need some sort of acceleration, and this is it. It's called centripetal acceleration. Centripetal acceleration points toward the center of our circle, and it's always perpendicular to our velocity vector. And to calculate it, the centripetal acceleration is just v squared divided by r. Now we'll take a look at some more examples of this tomorrow in class.